All right, this is our video lesson on the relationships between certain types of lines, and you'll see, I don't want to give the lesson title away yet. So I'm asking you in this do now activity to graph 2x plus 1, y equals 2x plus 1, and y equals 2x plus 4. So how would you do that? Well, y equals 2x plus 1, you identify the slope and the y-intercept. So y equals 2x plus 1. Here's my slope. Here's my y-intercept. And I would graph. So I start with the y-intercept. So that's going to be 1. So I go to 0, 1 on the y-axis. And the slope tells me to move up 2 to the right 1. So up 2 to the right 1. 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 And then you can go backwards. Once you get the general trend going forwards, I can go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, etc., etc., etc. And you get a bunch of points. And if you draw a nice, neat line, all those points will fit a line like that. Okay, so that's y equals 2x plus 1. Now I want to graph y equals 2x plus 4. Well, I hope that you notice the only thing that's different is the y-intercept, the starting location. So if I go up to 4, I'm just going to go up 2 over 1, up 2 over 1, up 2 over 1. And now I'm going to go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, etc., etc., etc. And I get another line. Let me make that line a little closer to what it should be. That's pretty good. So now I have two lines. I have, and actually I'll make this a blue line because it is supposed to be blue. Okay, so I have my two lines. I have my y equals 2x minus 1. 2x plus 1. And I have my y equals 2x plus 4. And it says, our question says, write a sentence describing what you notice about the graphs. So there's two parts to this. The graphs and their equations. There's two parts. Well, the graphs, if you notice, the word that we use for the graphs will never touch each other. Okay, no matter how far I go up or down, the graphs will never touch each other. And lines that don't touch each other are called parallel. So the lines are parallel. Then I asked you about the equations. I asked you about the equations. The equations if you notice, they share the same slope. But had a different y-intercept. So the y-intercept was different. And if you notice, the whole thing with the slope kind of said, all right, I'm going to start at a different point. So the y-intercept basically made us start at two different points. Okay? But then what happened was we moved the same direction. We went up 2 over 1, up 2 over 1. And what this creates is the effect that the lines will never touch each other. So our conclusion is that parallel lines have the same slope. And you might want to add here, but in parentheses, but different y-intercepts. And so now we have to kind of use this idea to do a lot of things. One thing we have to be able to do is ask ourselves, are two lines, are pairs of lines parallel or not parallel by looking at the equation? Well, if I look at number 1 here for a minute, if I look at number 1, I'm looking for equal slopes. So if I want to find out if lines are parallel, I want to find out if the lines have the same slope. So if I look, I have y equals negative 5x plus 4 and y equals negative 5x plus 7. Yes, lines are parallel because they have the same slope. And different y-intercepts. But if we look at number 2, the slopes are different now. The y-intercepts are the same. So if you think about what that means graphically, they're actually both lines are going to start at the same point. One's going to move up 2 over 1. The other one's going to move up 3 over 1. So you're going to get a line like this. Whoops, sorry. Should have passed through that y-intercept. And you're going to get a line like this. Clearly, they're not parallel. And so these are not parallel, different slopes. I'm going to do one more with you. I'm going to do number 4 with you. It says 2x plus 3y equals 6 and y equals 2/3 x plus 2. Problem with the first equation is it's not set up correctly. We have to get into y equals mx plus b form by solving for y. So we have 2x plus 3y equals 6. I'll put a box around my y. Subtract 2x from both sides. So I get 3y is negative 2x plus 6 divided by 3. And so y equals negative 2 over 3x plus 2. So now comparing that to y equals positive 2/3 x plus 2. And these are not parallel. This might be a little tricky, but the slopes, although they have the fraction 2 over 3, one of them is positive and one of them is negative. So one of the lines is going to go up, and one of the lines is going to go down. So not parallel, slopes are not equal. Okay? All right. That concludes that part of the lesson. And so now we're going to go to equations of lines parallel to the x and y axis. So step 1 says graph a horizontal line that passes through the point 1, 4. So the point 1, 4 is here. And I would like to graph a horizontal line. So if you think of you're at the beach, you look at the horizon. That's a kind of a flat, lazy surface in front of you. So here is my my line. There's my line. That is a horizontal line. It has slope of 0. And then it says make a table of points that are on this line. Well, clearly we know 1, 4 is on the line. And then I can make lots of other points. I could say negative 5, 4, negative 4, 4, negative 2, 4, 3, 4, 5, 4. It doesn't matter, just as long as you make a table of points that are on the line. 5, 4. I could do 6, 4. Okay? And the thing to notice about all of these points is that the y value is always equal to 4. No matter what x value you're at, the y value is always equal to 4. So the y value equals 4, always. And that's actually the equation of this line. This is the equation y equals 4. Now you might be confused. You're used to y equals mx plus b. Well, if we think about this for a minute, we know the y-intercept is 0, 4, so I can fill that in. That's my y-intercept. But then the slope. Well, the slope, I go up 0 to the right 1. So the slope is 0 over 1, or 0 over 2, or 0 over 6, whatever you want, if you wanted to travel from one point to another. So what happens is I get y equals 0x plus 4, and 0 times x is 0. So we just get y equals 4, the same thing that we noticed in the table of points. All right. So horizontal lines, okay, a picture would be like this. Okay, and say this is, I'm going to make up a number for this. This is 6. this equation would be y equals 6. So the equation of horizontal lines is always y equals just a number. It just equals its y-intercept. It cuts through, so imagine it's slicing through. It slices through the y-axis, and it slices through at that number, and it's parallel to the x-axis. So it's parallel to the x-axis. It doesn't cut through the x-axis. It's parallel to the x-axis. Some people call this a lazy line because it's just so flat. Okay, and the reason why it's a good idea maybe to call it a lazy line is because you see the y in lazy becomes a y equals number for the equation. I like to think of it as it cuts through the y-axis at a particular number. So you got to tell me what that number is. Just say y equals 6. Whoops. Where are the equations for the other stuff? I see what I did. Sorry. So let me just zoom out a little bit here for a second. So number 4, I forgot I had this set up this way. Number 4 says, what is the equation of the line, meaning this line? And the equation will be y equals 4. Okay. Then number 5 talks about a slightly different type of line. What is the equation of the line below? Well, it's not a y equals line this time. Okay. Because a y equals line would be going like this. It would be horizontal. This is a vertical line. So this line right here is a vertical line. And notice it's not cutting through the y-axis this time. It cuts through the x-axis. This is the x-axis. It's cutting through the x-axis at 3. So the equation of this line is not y equals, but x equals 3. So another way to remember this is if you are excited, you jump up and down. You're vertical. Jump up and down. An excited line starts off with an x equals and gives you the number. Okay? So let's go to our summary sheet here. Vertical lines, okay, our picture of a vertical line is like this. And it cuts through the x-axis at a number. So its equation is x equals a number. And like I said, it's like an excited line, kind of in contrast to our lazy line. In contrast to our lazy line, it's an excited line. So its equation is x equals a number. It cuts through the x-axis, but is parallel, meaning doesn't touch the y-axis. And that's that. And so the questions attached to this are going to be kind of lumped together and aren't quite on here. But that's pretty much it. Those are the concepts that are involved in this lesson.